All right, 10.4, number 6. So two titanium spheres approach each other head-on with the same speed and collide elastically. Okay? The fact that it's colliding elastically is super important, okay, because it gives us a really valuable problem-solving strategy, all right? So automatically, because of this collision, I know two things are going to be true. I know that the total momentum before they collide is going to equal the total momentum after they collide, okay? And what's the other thing that we know because it's elastic? Sure, we got Peter. Energy is conserved, right? Okay? And I showed you guys a super secret ninja trick that you could use in those elastic problems, right? What we started with was this. We said that the total kinetic energy before the collision is equal to the total kinetic energy after the collision. All right? So you can solve these problems using a system of equations, and these would be your two equations. All right? But this gets really messy, right? Because it's 1/2 mv squared plus 1/2 mv squared equals blah, 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 blah. Do you guys remember what the shortcut I showed you was?
Yes.
Yeah.
What do you got, Peter?
VF plus VI.
Yeah, your VF plus VI equals your VF plus VI. So this equation we want to replace with this. The velocity of object A initially plus the velocity of A final is equal to the velocity of B initial plus the velocity of B final. All right? So anytime you've got an elastic collision, you know these two things. Okay? Everybody good with that? All right, so let's see what else it tells us. It says, after the collision, one of the spheres, whose mass is 300 grams, remains at rest. And we need to find the mass of the other sphere. Okay? Wow, there is a lot of unknown information here, right? Two titanium spheres approach each other head-on. Oh, with the same speed. There we go. Okay, so here's my drawing. Sphere A, sphere B. They're both approaching each other with the same speed. So let's call that V. What do I have to call this one? Negative V. It tells us that one of the spheres has a mass of 300 grams. You want to make that A or B?
A.
Mass of A, 300 grams. Mass of B, something. Okay, let's see. After the collision, one of the spheres whose mass is 300 grams remains at rest. So here, the velocity of A final is 0. We don't know the velocity of B final. Good? All right. So, the question wants to know the mass of the other sphere. So there's two unknowns here, right? The mass and the velocity. Fortunately, we have two equations, right? Okay? So, thoughts? Sure, we got Adam, get us started.
I'd say you start by using the VAI plus VAF is equal to the...
Use this velocity equation.
Because there's only one unknown.
Yeah, if we think of the starting velocity as a known value, v, then, yeah, we only have one unknown, which is this final velocity, right? So, I think I agree with that. So let's see, if I plug in my numbers here, let's see, the velocity of A initial is v, velocity of A final is 0. That's got to equal the velocity of B initial, which is negative v, plus VBF. Oh, so VBF is 2v. Those negatives make a big difference there, don't they? Okay, so if you forgot that negative, that's what messed you up. All right, so was that one of the two questions, I think? Oh, sorry. Okay, so that's that. All right, so now we ought to be able to find the mass. So to find the mass, what equation should I use? The momentum equation, right? So here we go. The total momentum before the collision equals the total momentum after the collision. So we're going to have 300v plus the mass of B times negative v equals 0 plus the mass of B times 2v, right? And then we ought to be able to solve that. Let's see. So if I add this, I get 300v equals the mass of b times 3v, right? The v's cancel out. So 300 equals 3 times the mass of b. It looks to me like the mass of b is 100 grams. As a quick side note, notice the units don't matter here. You can use grams or kilograms here. Right? As long as you always use the same unit. Okay? The times when you need to worry about switching to kilograms is if you use like newtons, which has kilograms built into it, right? Or joules, which has kilograms built into it. Okay, here it doesn't matter. Evan. Oh, yeah. To here. Okay, so questions on how we found that mass? Everybody good? All right, part B says what's the speed of the two-sphere center of mass if the initial speed of each sphere is 2 meters a second. So, probably worth doing. Let's do this. So, are you good, Evan? Let's find the velocity of the center of mass initially. That's what it's asking for, right? So it tells us the initial speed is 2 meters a second. So, well, I should do the velocity of A initially times the mass of A plus the velocity, oops, typo. Velocity of B initially times the mass of B over the total mass, right? Yep. So that looks like it's going to be, oh, and it told us 2 meters a second, thank you. All right, so you got 2 times 300 plus negative 2 times 100 all over 400, right? Cool? All right, and so if you get that, you get 1 meter a second. All right, so that represents the velocity of the center of mass before the collision. So we've got these two particles. One of them has more mass than the other, so its velocity sort of counts more, right? This one has more mass, which is why the velocity of our center of mass is moving in a positive direction. Cool. What should the velocity of the center of mass be after the collision? Same thing, right? Why? No external net force, right? So the acceleration of our center of mass has to be 0. Let's check it and see if it works. Let's see. Did that do what I wanted it to? Okay. So let's find the velocity of the center of mass final. That's the velocity of A final times the mass of A plus the mass of B final. No, man, I am struggling. Velocity of B final times the mass of B all over the total mass, right? So what was the mass of A final? 0. So I get 0 times 300 plus V was 2, right? So I'm looking at 4. 2 times V would be 4 meters a second times 100 all over 400. And it gives you 1 meter a second again, right? So yay, physics. Okay? Notice, you guys, what is this? Isn't that the total final momentum? Right? And what was this? Total initial momentum, right? So when you find the velocity of your center of mass, you're just taking the total momentum of the system and dividing it by the total mass of the system, which gives you the velocity of the system. Cool? Right? Okay? Questions on this, you guys? Everybody happy with 6? All right, so let's do 7. And then, oh, thank you.